Hello, STT 315. This is recitation 6. So our learning objectives are to calculate probabilities from the cumulative distribution function or table, and calculate and interpret summary measures, expected value, variance, standard deviation for a discrete random variable. So task 1. India is the second most populous country in the world with a population of over 1 billion people. Although the government has offered various incentives for population control, some argue that the birth rate, especially in rural India, is still too high to be sustainable. A demographer assumes the following probability distribution for the household size in India. So here, this left-hand column is household size, so how many people are living in the household, and then this right-hand side is the probability associated to each value in the left-hand column. What is the probability that there are fewer than 5 members in a household? So here, I would take a pause and write out this table. So the probability that we have fewer than 5 members is going to be the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. And so when you add up those probabilities, you get 0.5. So if we add up these probabilities, 1 through 4, you'll get 0.5, because that's the probability there are fewer than 5 members in the household. Okay. What is the probability that there are 5 or more members in a household in India? So the probability of 5 or more is going to be the probability of 5 plus the probability of 6 plus the probability of 7 plus the probability of 8. So when you add up those, you'll get 0.5. Then part C, what is the probability that the number of members in a household in India is strictly between 3 and 6, not including the endpoints 3 and 6? So that would be, since 3 and 6 are not included, that would be 4 and 5. So we would want to add up these probabilities, 4 and 5. And so we get 0.24 plus 0.25, which equals 0.49. Consider the following cumulative probability distribution. So here we have the probability that x is less than or equal to x for 0 through 5. And so here are the cumulative probabilities. So calculate the probability that x is less than or equal to 3. So here, by definition, that's going to be 0.78, because this is the probability that x is less than or equal to 3, as we can see here by definition as well. Calculate the probability that x equals 3. So in order to find that, we need to take the probability that x is less than or equal to 3, which we found in part A, and then subtract the probability that x is less than or equal to 2, and then we'll isolate probability x is equal to 3. And so the probability that x is less than or equal to 2 is 0.52. So if we take 0.78 minus 0.52, we get 0.26. Calculate the probability that x is in between 2 and 4. So that's going to be the probability that x is less than or equal to 4 minus the probability that x is less than or equal to 1. So that's going to be 0.84 minus 0.35. So that's 0.49. The number of houses that a realtor sells over a 1-month period has the following probability distribution. So this left-hand column is the number of houses sold, and this right-hand side is the probabilities associated with that, the left-hand column. This is the same table. On average, how many houses is the realtor expected to sell over a 1-month period? So here, this keyword expected is signaling that we're going to want to take, or on average, that's another keyword, how many houses is a realtor expected to sell? So this is essentially asking us to take the expectation. So in order to take the expectation of x, we're going to do the sum of our x times the probability of x. So if we go to the table, here are this left-hand column is like the values that x can take. And then this right-hand side is the probability. So we're going to do 0 times 0.3 plus 1 times 0.5 plus 2 times 0.15 plus 3 times 0.05. So when you do that, you get 0.95 is the expectation. And then it also asks for the standard deviation of this probability distribution. So to find the standard deviation, you first have to find the variance, and then once you compute the variance, you'll take the square root to get the standard deviation. So if we go back, so the variance is the sum of the x squared probability of x minus the expectation squared. So we already found the expectation from the previous part, which is 0.95. So we'll square that. But first we want to find, now we have to do x squared times that probability. So that's going to be 0 squared times 0.3, 1 squared, which is 1 times 0.5, 2 squared times 0.15, and 3 squared times 0.05. So when you simplify, you get 0.6475 once you do that and subtract this expectation squared. So then we're not done yet because we have to take the square root to get the standard deviation. So once we take the square root, we get 0.804674, or in other words, 0.80. A marketing firm is considering making up to 3 new hires. Given its specific needs, the management feels that there is a 60% chance of hiring at least 2 candidates. There is only a 5% chance that it will not make any hires and a 10% chance that it will make all 3 hires. What is the probability that the firm will make at least 1 hire? So the probability that the firm will make at least 1 hire is 1 minus the probability that x equals 0, meaning that they won't make any hires. And we were told that there's a 5% chance that they won't make any hires. So the probability that x equals 0 is 0.05 or 5%. So if you do 1 minus 5% or 0.05, you get 0.95, which is the answer. And then find the expected value and standard deviation of the number of hires. So first, let's find the expected value, since we then need that to find the standard deviation. So here, as a reminder, the expected value of x is the sum of x times the probability of x. And so this right-hand side is the information that we were given. We were given that the probability of no hires is 0.05. We were also given that a 10% chance that they will make all 3 hires. So that's the probability that x equals 3 is 0.10. And then we were also given that there's a 60% chance of hiring at least 2 candidates. So that's the probability of x greater than or equal to 2, because at least 2 means equal to 2 or more than 2. So that's 0.6. And so now we want to come up with the associated probabilities for each value that x can take. So the probability that x equals 0, this was given to us. It was 0.05. And the probability that x equals 3, that was also given to us. But now we need to use this information to find what the probability that x equals 1 and the probability that x equals 2. So let's first look at the probability that x equals 2. So that's going to equal the probability that x is greater than or equal to 2 minus the probability that x equals 3. And so we were given both of these information. So the probability that x is greater than or equal to 2 is 0.6. And the probability that x equals 3 is 0.10. So if you do this, or if you simplify this, you get 0.5 as the probability that x equals 2. Then, because we need to, for the last missing value, we need to make sure that all of these sum to 1. we can do 1 minus the values that we already found, which is, or were given. So it would be 1 minus 0.05, we knew it was given, minus 0.5, which is what we just calculated, and then minus 0.1, we were also given that information. And so when you do that, you get 0.35, so that's the probability that x equals 1. Okay, so now that we have this information, we can find the expectation. So the expectation is the sum of x times the probability of x. So that's going to be 0 times 0.05 plus 1 times 0.35 plus 2 times 0.5 plus 3 times 0.1. And so when you simplify, you get 1.65. That is the expected value or the expectation. But we also want to find the standard deviation. So we need to find the variance and then take the square root. And so the variance is the sum of x squared times the probability of x minus the expectation whole squared. So we already found that the expectation was 1.65. So we'll find this and then subtract 1.65 squared. So if we go back to this, we would be doing 0 squared times 0.05 plus 1 squared times 0.35 plus 2 squared times 0.5 plus 3 squared times 0.1. And so that minus the expectation squared is 0.5275. So that is the variance, but it's asking for the standard deviation. So in order to find the standard deviation, we're going to take the square root of the variance. So that's the square root of 0.5275, and we get 0.7263.